Okay, so the next big topic is control flow, and that's actually more what programming is about than what we've done so far. So far we've seen kind of essentially a lot of basic stuff to organize data, quantitative data, numbers, to put them into variables, various variable types, and then to put them into bigger data containers like matrices, vectors, and cell arrays and structures. But of course, when programming, you don't only put data somewhere and then extract data again, but you want to do something with it, and that's the main topic of control flow. So once you are happy with control flow, especially for loops, then I think you are on a good way to become an efficient data scientist. And that's kind of the topic then. So the big topic is control flow, and I'm using here the MATLAB editor now to tell you what we're talking about, so that I'm not programming anything right now. So the first thing that we need to talk about are logical expressions. They are still somewhat static, but are required. Same thing for conditional statements, because these logical expressions and conditional statements, they give the structure to your control flow. And then we will talk about the more interesting things, namely for and while loops. So they really put some dynamic in your coding. And anything else? No, that's essentially what we want to do. So maybe we split this into for loops, and then after that we talk about while loops. And especially for and while loops, they are really at the heart of programming, because they allow you to exploit the programming paradigm, in the sense that you want the computer to do simple things that you can't be bothered to do again and again. You want the computer to do that, and you want to you want to use the computer to make your life easier. So the first thing then to talk about are logical expressions, and we have seen that before. So, or at least in parts. So logical expressions. These are little statements that can be true or false, and that you often use to structure your programming code. And essentially you just need to be familiar with the way you write them. So if you assume that you have two numerical variables, let's scalar variables, so x and y are scalar variables. For example, x is 2 and y is 1. Then you can test a number of logical expressions on them. The first thing that you've already seen when we did this find is a test for equality. So, and to test for the equality of x and y, you do the following: x, y. So here the important thing is that you have two equal signs. So this is not an assignment, but it tells MATLAB to test whether x equals y. And then there are two possible outcomes, namely x equals y is true, or x equals y is false. And what is the outcome here? If x, in the example that x is 2 and y is 1. it's false. So they are not equal. So let's have a brief look. So x2, y1, and now x equals y. It returns a logical data variable, which, as we discussed earlier, can be 0 and 1. And here, of course, it's 0 because 2 is not equal to 1. Of course, if we set y to 2 and then test whether they are equal, we get a logical 1. So we get a true statement. And these kind of logical expressions, there's not only equality, but there's also inequality. So that tests whether x is different from y, and that uses this tilde equal sign. That's the way to write it in MATLAB. And of course, if we are in this case that x equals 2 and y equals 1, then this is true and this is false. And then we can also test for numerical relations or inequalities actually. Let's call them relations. So we can check whether x is smaller than y, whether x is larger than y, whether x is smaller or equal to y, or whether x is larger or equal to y. Yeah. So all of these expressions return 0 or 1, and that's essentially all there is to say about them. What one can do is concatenate logical expressions. So using what is known as logical AND and logical OR. So if you have 3 variables, let's say x is 2, y is 1, and z is 0, then you can test whether, for example, x is larger than y. So what does that return here? Sorry? The question is, what is, so I defined now 3 variables, x2, x being 2, y equals 1, and z being 0. And now I test the logical expression x larger than y. So what does that return? It's true, because 2 is larger than 1. And now I can expand on this logical expression by testing whether at the same time z is larger than y. So what is the outcome here? That's false. And then if you're familiar with logical AND, which one would hope, is so the logical AND is true if both statements are true, or both statements are false, but not if one of them is true and the other one is false. So that's logical AND. So in this case, it basically asks the question: is x larger than y, which is true, and at the same time is z larger than y? And that's false. So the whole statement is false. Yeah? So that's the logical AND. If you need to familiarize yourself again, there's of course always help. That's the logical AND, and I guess if you look for this, you learn more about it. So that's a way to concatenate logical statements with the logical end, which is then also which is only true if both of them are true. There is the logical OR, which tests if one or the other is true. So let's look at that again. So the other way to do is something like this: x larger than y, which is true, or z larger than y, which is false. But because you're now testing for the non-exclusive OR, this statement is actually true because one of them is true. So I think the easiest to get familiar with these is actually in examples. So we leave them for now, and we will see them. So these logical expressions now in many examples, and there it's I think makes more sense to think about them rather than on their own. Sometimes you might come across the fact that in MATLAB there are actually two ways to write logical AND or conditions, namely with one AND and with two ANDs. So for scalar variables, this is actually the same thing. This only works for scalars, so the double AND, and is said to be more efficient in the sense that it, if it already finds that one of them is false, then this whole thing isn't true. I think earlier I said that if the logical AND, if both are false, then this is true, but this is not true. So if both are false, then the whole thing is also false. Just to correct that. So if you use this double AND, it only checks this one first. If it finds that this is false, then the whole statement is evaluated false. So it's more efficient. But whenever, maybe this will also come up again, you don't have to worry about efficiency because things are so fast that it doesn't really matter. The major difference is that this double AND only works on scalar expressions and not on arrays. And this single AND also works on arrays. But to become familiar with how what actually happens if you here have not logical scalars, so if you don't only have false and true and false for these, but logical arrays, so a vector of true or false statements, that's a little bit more advanced, so I'm not doing that here because we won't need it for the examples. Yeah. So in general, these double AND and double OR, as long as you're dealing with scalars, it doesn't make any difference. And in general, it's also in your basic programming, you will only ever have logical scalars. So yeah, that's the story about these double signs. Good. So why have we talked about this? Because we will need these logical expressions in if statements. Are there questions right now about logical statements? Essentially, they are ways to evaluate whether two variables are the same or have a certain relationship and can be true or false. And the important thing is that they can be used as conditions in if statements. So this is why they are interesting. So the next, or the first real element of control flow is then the if statement. And that's the next topic. So that's the if statement. Maybe I should have used something nicer here. So the if statement is a basic element of control flow, that always has the same form. So if, and then a condition, if this condition holds, so if condition evaluates to logical true, then the code that is written below, or not below, but inside the if statement is executed. And if this condition does not hold true, then this code that is written here is not executed. And the if statement in MATLAB always has this form. So if, then here there needs to be a logical condition, there needs to be some code, and then there is the end statement. So now let's look at this in action. So let's call this overview and come up with a script. So remember, what I'm doing here is now specify an M file which I can run using, for example, this. And we will come back later to the question why I put function up there. Now I want to show you some basic functionality of the if statement. So let's assume we define a variable num, and we say this is 1. And then now we come up with a if statement. We use the keyword or the reserved word if, and then we do a logical expression. So we need some kind of condition. So if num is larger than 0, for example, which as you can see here is true because num is 1. If num is larger than 1, we use keyboard. Does any one of you remember what keyboard does? Haven't seen it. Keyboard, I use it quite often as a debugging tool. If you're executing a MATLAB M file, maybe we dock that here. Oops. If you're using a MATLAB M file, keyboard returns control to the command window. So what will happen is if I run this now, because num is larger than 0, once the code arrives at keyboard, I will be I will have control. So you see the screen error, and you see that there's a K here. And the nice thing about this is that I now can look into the workspace and see what is in the workspace. So basically the code is executed until here, where you have the keyboard, and then you are basically see the workspace as it was defined inside this script in the command window. So this is really, so I use that a lot for debugging. Of course, there are more, there are debugging tools in MATLAB that they actually want you to use. Using these dots and so on, and the interface for debugging, but I somehow stick to using keyboard so that I can stop the code and look what's going on and what the values are. So maybe another example, that doesn't use a keyboard, so is to print something. So if num, so now I changed this here actually, is smaller than 0, which is now not the case, so it will not happen. But if num is larger than 0, print something. If num is 0, for example, we do print hello. Okay, so it's a little bit of a shame because the sun is never out this winter. But okay, so now I want to print something. So if I go out here, now this is not executed because num is 1, so it's not smaller than 0. So we will not get here, but we will get here and print something. So you see that now there was this hello printed. Actually, if I put this, then it actually looks a little bit nicer when I print something. So let's put in also some cleanup here. So yeah, so because this was true, it printed hello. So if the if statement can be expanded on, namely now the only thing that happens is if this condition is true, then this is executed, and otherwise yeah, it's ignored. But one can basically branch this in the sense that one can specify something as under else. So if num is larger than 0, print something, else yeah, return control to keyboard. So if num is larger than 0, print this, else we use this keyboard. Now if I run this, of course, so let's get rid of this here, because num is still larger than 0, it's as before. And now if I change num to 0, we get here, and yeah, keyboard is invoked. So MATLAB goes over this code. If num larger than 0, print this. Num is 0, so it's not larger than 0. So it this is false. It doesn't do that. But then it goes into else. If this is essentially not true, then do this. Yeah? So it is. So these if and else statements, they are relatively straightforward because they correspond to your basic language intuition about this. Now one can also expand on if statements by two other things. Namely, one thing is that one, instead of having only the else, one can specify an else if. So instead of having only the else, one can say else if, and then one needs another condition, else if num equals 0, print f, maybe make it a little bit more meaningful now. Num is 0. Num is larger than 0. So so what do you think happens now? If I run this code, what is printed? Sorry? Yeah, so what? So what is going to be printed? Why? If you look at the code.
Oh, no, it is.
Yeah. So what is then going to be printed? Yeah. Exactly. As you see there. So that's one way to expand on if statements, so to have else if and not, so basically introduce another condition. Something else you can do to expand on if statements is to come up with what is known as nested if statements. So, for example, if you have num like this, you can put an if statement also into the branch of an if statement that starts with an else. Could also have an else if here, but I'm doing it now just with the simple else. So if num is larger than 0, then print num is larger than 0. Else, if num equals 0, print num is equal to 0. Else, if num is smaller than 0, of course f, print f num is smaller than 0. Now, of course, this comment doesn't work anymore. On the if statement. And here you see a nested code. So nested code, it's always good practice, and MATLAB does that automatically, is to indent this so that you can clearly see what's going on. So if num is equal to 0, this is executed, else this part of the code is executed, but here again it checks what's going on with num. So if this num is actually 0, then this is printed. Else, if num is smaller than 0, num is smaller than 0 is printed. So, for example, if we now put here -2, what is printed?
Num is smaller than 0.
It's pretty simple because it's it says what's going on, but you have a question.
Why is an else if indented with else?
So why? What's
Why is it on the same indent as else? Why does it go else if, not else if? Shouldn't it be if, else, else if?
No.
Why is there an indent to else if? Yeah.
This one?
Yeah, why shouldn't it be?
Okay, that's a good question, because this belongs to this if statement. Yeah. So this so if and else you can only have two. If you have else if here, you could have another else if down here, which then belongs to this if. But here, because you started a new if statement, this else if belongs to this if statement. Yeah, that's a good question. So the if always starts a new if statement, and then what follows in terms of else and if belongs to that if statement.
I have another question.
Yeah.
It's kind of related, but is print the same as this?
Yeah, print. Yeah, yes and no. So disp is the poor man's fprintf, I would say. So I use disp way too long. So fprintf is a little bit nicer in terms of what it allows you to format numbers into, but also a little bit more advanced. So fprintf, it allows you to do many different things, and specifically if you want to visualize numbers. Disp is a very basic version that works differently. So I don't want to go into details now, but here I'm using essentially the fprintf. I could have also used disp here, and I wouldn't have to put this new line character actually in there. Good. So there are a number of examples in the script that you can look at. But I think for now that's about what I want to say about the if statement. Good. You can make if statements arbitrarily complex, and if you, for example, work with the Atterwald book, there are millions of examples where you can sharpen your tools or your knowledge about if statements. In general, I would not recommend to do it overdo it with if statements, because if you have a single if branch, then you know what's going on. But if you do multiple if branches, perhaps with nested if statements and else if statements, you might get lost of the logic that you're actually writing up. So in general, I recommend to leave the complexity of if statements a little bit on the low end, because then you know much better what's going on. In these tutorial examples that you find in books, of course, they like to play with the logic and you start thinking about it, and then they make things more complex than you would necessarily use them in real-life programming. So don't overdo it with the if statements. Good. Any other questions about if right now? No. Good. Then the next thing are for loops. And for loops are what I use in programming every day, and for me, for loops are really the essence of programming. So that's for me, that's the high point of the morning. For loops. So, do you agree that for loops are the essence of programming? Or what? They're useful. That's a very diplomatic statement. So I think for me, for loops are the essence of programming, because they you do programming not to, in my opinion, to come up with complicated logical expressions that you don't understand anymore, but maybe the computer knows what it's doing and so on. But I use programming, or what I see programming is as making human life easier. And what makes human life sometimes hard is that you have to do mundane things again and again and again. And a computer allows you to automatize this. And that's what a for loop does. So now let's talk about for loops. So for loops have a specific MATLAB syntax. For different languages, they look, of course, a little bit different, but essentially they all do the same thing. So for loops allow you to iterate through a set of actions. So essentially to repeat a specific set of actions in creative ways. They have this general format of this form. So you need a loop variable, and you need to specify a range for the loop variable, and then according to the specifications, the action that you want to do is performed as many times as the loop variable and the range specify. So let's go here and look at a concrete example. So maybe let's get rid of this. So as a first example, if we write for e, which is now a loop variable, and specify its range to be 1 to 5, and then say fprintf this manner. So this percentage sign in the fprintf statement says that here one of the numbers that are specified as second argument should be put in. Then we can format this in different ways. So D is one formatting way to do that, and then there's the new line character that says after you've done that, start a new line. So if we use this code and now dock this again, what will happen is that this action is executed every time this for loop is executed, and the for loop is executed according to this specification. So it says for e going from 1 to 5, print e, that's essentially what it's saying. And then it works as follows. So the first value that e takes on is the first value in its range. So it takes on the value 1. Then fprintf prints 1. Then e goes to 2. Then fprintf prints 2. Then e goes to 3. It prints 3. It goes to 4. It prints 4. It goes to 5. It prints 5. So one can, of course, I would call it hack into for loops. So, for example, if you're not quite sure of what's going on here, you could put in an if statement. So if e equals 2, return control to the keyboard. So what will happen now is that e starts at 1, it's get printed, then it goes to this code, e equals 2, it's not 2, so it goes to the end of the for loop, then starts again with the beginning of the for loop and with e set to 2. So let's run this. So you see that it's printed 1, then it goes to e equals 2, it prints this, but after it has printed it, this evaluation here becomes true, so we get to keyboard. Yeah.
Can you repeat what the percent means?
Yeah, that's maybe it's a little bit. That's actually not the content of the what I want to talk about. So the percent D is the fprintf. E is this. So this here is a string. This is the string that is printed, and now I put in a little bit more of a string that one can read. So I is, and then the percent indicates to fprintf it should take this I and in the string put in the number that I takes on currently in a specific format, which is given by D, and you can look up what this D means if you go to help f printf. So such as D, so this is the conversion character, for example, D, and then you can look at examples what these different conversions character are. So I hope I find a This is then the example. So this is actually quite complex. So you can do all sorts of formatting for your number when you print it. This is what is explained here. So with the D, it's with respect to base 10. It doesn't really matter right now. And then the last thing is just it starts a new line. Yeah. You can also do that if you like this more. You can also use, you can achieve the same thing by using disp and concatenating a string with the number or the numerical value I converted to string. It's the wrong bracket. That does exactly the same thing. That does exactly the same thing using disp, but fprintf is more professional and more versatile. Yeah? So if we look at this, now we get it, the same thing from fprintf and from disp. So this is why we get it twice. And again, it stops when I is 2 and goes to keyword. Yeah. Good. So the thing with the I is you don't need to use the loop variable for anything inside your for loop. So you can also, for example, just print something here. As often as you want it without using the I at all. So now you have a for loop that prints the statement here as often as this for loop is executed, and it's executed, as you can see, 5 times. So you can do that without using the I for something. What one can use for loops for example, is to allocate certain data to arrays. So one can, of course, combine all these programming concepts that I'm telling you about. So, for example, if you want to write the square of I into an array, and you want I to go from 1 to 5, so you want, for some reason, you want 1 square, 2 square, 3 square, 4 square, and 5 square in an array. What you can do is to start an array, let's call it X, and you actually don't have to, but I would always recommend to do so to initialize this array. So, for example, specify a none array with 5 entries, and then you can use indexing of this array to allocate something as a function of I. So what this does is, first it creates an array of 1 row with 5 columns, and then it runs through this for loop, and first the loop variable is 1, and then it addresses the first element of X and assigns to it I square, so 1 square, which is 1. Then it goes to the end of the for loop, and I now takes on the value 2, and then it addresses the second element of this array and assigns to it the value 2 square, so you get 4 there. So if you, and of course this goes on until 5, so the last element will be 5 squared, so 25. So that looks like this if you execute it. Actually, you this is also helpful if you want to see the output of each for loop. You don't have to put a semicolon here, so you remember that if you put a semicolon, you don't see the output. But if you don't put a semicolon, you actually see what's going on. So let's maybe remove all semicolons here. So the first thing that happens is that X is initialized as an all none array, and then I is 1, and you get this allocation. So what I sometimes do is also to simply print the loop variable, then it's even more informative. So then you see even more what's going on. So X starts here, then I is 1, and X at location 1 is assigned 1. Then I goes to 2, X at location 2 is assigned 4, I goes to 3, X at location 3 is located X 3 square, which is also I square, which is 3, goes to 4, same thing happens, but 4 square is assigned to location 4, and then 4, 5. Yeah? Questions about this example? No? Good. So then one thing that is very helpful in addition to that is to nest for loops. And yeah, here I show you an example how to do nested for loops for filling in a matrix. Maybe just before I do that, you don't have to initialize this in MATLAB, so you don't have to specify X before you fill it in. So you can also do something like this, where then MATLAB actually dynamically allocates this variable. And here you see that it says the variable X appears to change size on every loop iteration. Consider pre-allocation for speed. So MATLAB in principle doesn't like that if you build up a variable, here a numerical array in a for loop, and it talks about speed. I would rather talk about logic of programming. So it works, so it does what it's supposed to do. It still builds up this array, but it's creating new variables, so it changes X all the time during this for loop. So I really recommend to always, before you fill in something, to initialize this. Then the memory is already allocated. This is what MATLAB thinks in terms of speed, so it doesn't need to look for free memory. For these small examples, doesn't make any difference whatsoever. But it's also more logical. You have something that you then fill in terms of an array, and you're not building something on the fly. Good, I just wanted to say that. Now let's go to nested for loops, where we also use this initialization. So the example is here. We want to fill in the entries of a 3x4 matrix with the integers from 1 to 12 in a row-wise fashion. So essentially you want to create the matrix that looks like this. 3x4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that's already it. So we want to create this matrix now using nested for loops. Of course, we can specify it by hand, but usually you want to not do that, but automate things. So to do this with nested for loops would be as follows. Let's maybe keep that here. So first we define number of rows and columns of the matrix that we want to create. So number of rows be 3, and number of columns would be 4. Actually, I did it wrong here, so we do 4 rows and 3 columns. No, what am I doing? 3 rows and 4 columns. That's what I want. This is what I did here. So 3 rows, 4 columns. Just confused myself for whatever reason. And then we initialize our array to nonce. So we set A to be an array of nonce with n rows, so 3 rows and n columns. And now we do the following. We first set the first element to A, to 1, sorry, initialize element of A. So we set small a to 1. And then we do a nested for loop. So we now cycle over this matrix here, and we cycle over it over each rows and its columns. So iterate or cycle over rows. So we go I from 1 to n row. So what does this produce? Exactly. So this creates 1, 2, 3, and then when we are here, we are at, for example, I being 1, and now for a fixed row, iterate over columns. So we put in another for loop into this for loop. That's the idea of a nested for loop, and put in here this. So what does this produce? 1, 2.
4.
1, 2.
4.
No, say it again. Yeah, I just.
4. No.
No, this statement here.
1, 2.
Yes, that's right. So you said 1, 2, 4, right? Yeah. No. It's, why do you say 1, 2, 4?
And all is 4.
Yeah, but what about the 3?
The 3 is just number of rows.
Yeah, but this is the colon notation for increasing by 1. So, any other opinions of what this produces? So the suggestion is that it produces 1, 2, 4. So what's the second word? Is it a 2 or is it a 2? So it's a TWO?
No, T-O.
TO. I got it. Because yeah, good. Sorry, I was thinking you're talking about 1,
No.
2, 4, but you were talking about 1, 2, 4. Now I got you. Thanks. But this is good. So yeah, this is producing the numbers 1, 2, 3, 4. Good. Then we can fill in finally our matrix element. So we index the matrix A that we have created here now in the ith row and the jth column, and we put in A. Now if I would just, of course I have to put ends here for this for loop and for this for loop. If I would run this code, what would I get? For A. So if I then put A here and look at it, what do I get?
1.
1? What do you mean by 1?
At every position.
Hmm?
Would make.
So A is 1. Yeah? So sorry, small a is 1. And now I run this for loop, and it starts with I being 1, and then it runs this other for loop over columns, so 1, 2, 3, 4. and it always fills in this matrix element. So how does my matrix A look once these two for loops are done?
Every element is A.
Every element is A. Yeah, every element is A, that's true, but what is then A?
Matrix.
So how does the matrix look? So what are the elements of the matrix?
3 times 4.
And the elements of which are what?
A is 1.
Yeah.
Okay, I can see.
So how does A look? So if I look at this here,
3 by 4
identity matrix?
Identity ones then. Like every element is 1.
Every element is 1, exactly. So that's what this is what I wanted to hear. So it's not the identity matrix, because the identity matrix has ones only at the diagonal, everything else is 0. But here, every element that is filled in is equal to 1. So we get this. Yeah. But this is not what we wanted, because we wanted this matrix. So now once the first element is put in as 1, then we update the matrix element for the next location. That is, we set A to A plus 1. Yeah. So if it's now running this for loop over columns, then it first puts in 1, then it goes to the second column, puts in 1, goes here, changes the small a to 1 plus 1, which is 2, and then goes to the second column and puts in here 2, and then it increases it again. And then once it's done over columns, A has already been increased, so it's 5, and then goes to the second column. Yeah? So if we run this, we actually get what we want. So I think this is actually where you should start. So I think a lot of the stuff that I told you about was so far fairly easy. Here you need to start thinking a little bit more, right? So you have to. And this is the only way you ever really get to programming. You have to think line by line, and then you have to think, especially with for loops, iteration by iteration. Yeah. So it doesn't make sense to look at the whole statement and then using some Gestalt psychology and try to understand what's going on, because you see it like that. This is what you can do once you have quite some experience with programming. To make sure that you understand what's going on, you have to basically play this out in your head or maybe even on paper to make sure that you understand what's going on, especially with this overwriting an element, adding 1. So it's something that one needs to practice. So maybe, because we heard about the identity matrix, if we want to create the identity matrix with this loop, what would you do?
You use it set the element 1.
Yeah, exactly. So now we change this. So one way to achieve that is, and if it's not, what do I do then? 0. Yeah, exactly. If we here put a if statement in to the inner for loop, if I equals j, so if the row and column index are identical, of course we need to really get an identity matrix, we have to have the same number of rows and columns, of course, because other identity matrices are not defined. So we have now a 4x4 identity matrix. If the row and the column indices are the same, then we say I j equals 1, else, so if they are not the same, we say I j 0. This we don't need anymore. And then we get the identity matrix. As you can see. We can of course do a different thing else if I is larger than j. So if the row index is larger than the column index, which is of course the lower half of the matrix, for example, if you're in the 4th row and the 1st column, we could set this to 2 maybe, and else if we're in the upper part, if I is smaller than j, I j minus 2, then we get, for example, this, where we have minus 2 above the main diagonal and 2 is below the main diagonal. Good, so this is stuff on for loops. Yeah, so the main thing about for loops is that you need to play them through in your head. That's the only thing that I can recommend. So it's not that it just naturally everything is clear, but you have to always think about what's happening. And what's really helpful when you're programming is to put up some comments. So for example, in this case, I ignored putting up comments. So here, yeah, for example, you could write something like put 1 on diagonal elements, put 2 on elements below the main diagonal, below the diagonal, and here if I is smaller than j, yeah. So in general, especially when you're dealing with nested for loops, comments, so that the reader of your code knows that you know what you're doing, and often the reader of your code is yourself a couple of months later. So yeah, it's definitely helpful to put in a lot of comments. I'm just gonna say that. Now, there is another iteration loop in MATLAB, in general programming, which is not the for loop, but the while loop. So that's the last thing to talk about. The while loop. The while loop works different from the for loop in the sense that it doesn't use a pre-specified loop variable and its range, but it tests a condition, yeah, like a logical condition. So it has this general form while condition. So while this condition is true, carry out action, and once this condition is not true anymore, don't carry it out anymore. So while loops, I use while loops a lot less than for loops, because while loops, in while loops you always have to, yeah, it's a conditional issue, so you don't do something a pre-specified number of times, so for example 1,000 times, but it depends on something. So while loops are, of course, if you're doing some kind of optimization or so, they are used quite a lot in the sense that you want to minimize something, and once you have minimized something to a specific degree, you say, okay, now that's enough. Or if you're doing experiments and you're waiting for something, for example, you want to show something, and then you wait for a subject or participant response, and there while loops are helpful. In general, you often know what's going on and how often you want to repeat a statement, so you can get very far with for loops. But yeah, nevertheless, want to show you while loops. So yeah, I think a nice example for a while loop that doesn't involve any math is actually to use a while loop when you want to record participant input. Let's look at this example then. So the idea is you prompt a participant to input something. So you use the MATLAB function input, where you can specify a string that tells something to the participant, enter a positive number, and once this is done, this is actually allocated to input num. So let me show that previously before we do the. Let's just get rid of this here. Now the participant is prompted to enter a positive number. Once this is done, and so you put in a number and press enter, this input num is allocated the number that was entered. So input num, as you can see, is now 2. Now, where does the while loop come in this case? In terms of specifying a condition, what we're using here is input num smaller or equal to 0. So this is the participant or the user should enter a positive number. Now, if the user enters enters a negative number or 0, input num is of course negative or 0. So this condition becomes true, and then you can, for example, allocate input num again with input and remind the participant that this was not correct, and ask them kindly again to enter a positive number. Now, two things are possible. Either the participant finally gets what she has to do, namely to enter a positive number. Then this condition is not true anymore and the while loop ends. Otherwise, if it's still a negative number or 0, the while loop keeps on executing. So let's have a look at that. Let's dock this again. Enter a positive number. I'm giving it a -1. This is of course invalid, and it asks me to enter a positive number. I think I actually don't want to see this for now. So let's remove this. So enter a positive number. I give it a -1. It says it's now in the while loop and says invalid. Please enter a positive number. I give it a -2. It stays in the while loop. And I didn't specify how often it should do this because it's not a for loop, it's a while loop. It just will stay in there as long as I don't manage to give it a positive number. Okay? And now I give it a positive number and it leaves the while loop. So the important thing about the while loop is this condition, and what is more important than that, how that looks, is that if you're using while loops, that you make sure that the condition can actually become false, because otherwise your while loop will never end and you have a problem. So for example, if you write something like this, while 2 is larger than 1, fprint f infinite while loop. So 2 is always larger than 1. There's nothing that will make 2 smaller than 1. So I can execute this. Or not, because it already, why does it not execute? Output infinite while loop, output truncated. Okay, so it at one point it doesn't want to show that anymore. That's funny. Oh Jesus, but it's still running. It just doesn't show the output anymore. So it's still running actually. It has, what does it do? So if you, let's look at that again. So now it's writing it. It continues to write this infinite while loop. Because it was all one below the other, it didn't like that. So now it's running this while loop and will do so until the end of time. And it will not stop. But of course we can stop it using Control C, which stops that. We can actually make this more interesting. MATLAB count. MATLAB count. So now it should print I, and then we increase I. Let's see how fast MATLAB can count. Yeah, it's again doesn't like that. So now it's counting. Very fast in counting. But it's not that fast. I mean, it's actually faster than this looks because the printing takes the most time. So if you wouldn't print it, then MATLAB would count a lot faster. How long do you want to watch it? It's reached 1 million.
Can we write stop after 3 seconds?
You can, in principle, do something like that with while loops. So if you use what is known as a tick and tock, so these are actually, they measure elapsed time. So if you want to do that, so you would have to, one thing you could do is start that here and then say if tock is larger than, is it in seconds, I think? Doesn't measure it in seconds. I haven't used tick and tock forever. Doesn't tell actually. If torque is larger than, I think it's in seconds. Torque is larger than 10. What you can do also with for loops is a break command. So break, if this is reached, actually terminates the for or while loop. So this should now only do it for 6 seconds, if it's actually measured in seconds. So measure in minutes. seems to be in seconds. So you can do that. But in general, I would recommend stay away from while loops. Only if you really need them to record participant responses, or if you're using some optimization where you have a stopping criterion. But this is, so the first is actually something that will be come across as soon as you start writing experimental code. The second, in terms of optimization routines, might be a little bit further down the line once you decided that SPM is not doing what you want and you want your own optimization code. Okay, so I would. So this is what I wanted to say about control flow. There is something in addition to if, which is called switch in MATLAB. So you can look more into that. It does the same thing as if statements, essentially. There's also something in MATLAB in terms of control flow that is try, and that allows you to basically have code that is executed even if errors are issued. So you can also more look into that. Specifically if you're looking into SPM code, you will come across these try things. I don't think try is, and also, I mean, switch, yeah, you can use switch. Try is not, I don't like that, because you write code that might not work, and then you have some other code that might take care of that. So it's not really hard to keep track of what's going on. So I don't recommend these try statements. So questions about control flow in MATLAB. Of course, these are just basic tools right now, and the real programming is then to put all these things together. Okay, so then I would propose that we stop here and take a lunch break until 1, and after the lunch break, I tell you about my second most favorite concept, program concept. The first one is for loops, and the second one is functions. So functions is the next topic. Okay. Sorry? Good. Let's then stop that.